Topic 2 of ocean basins, continental margins. Continental margins can be either active or passive. So in this map you see the active margins highlighted in pink and the passive margins highlighted in blue. Here we're looking at a passive continental margin. If you imagine yourself standing at the continental edge on the continents looking out into the ocean, if you see a spreading ridge, you have a passive continental margin. So passive continental margins are facing the edges of diverging plates. Here in this image, we're looking at an active continental margin. You see, in the image, you see the South American plate. If you're standing on the western edge of the continent and you're looking out into the Pacific Ocean, imagine the ocean would be drained of the water. You would see a trench, you would see an active margin, you would see a subduction zone. And these active margins, they are associated with a lot of geological activities such as earthquakes and volcanism. If you stand on the east coast of the South American plate and you look out to the Pacific Ocean, to the Atlantic Ocean, you see a spreading ridge. The plate boundary you see in the Atlantic is a spreading ridge, and therefore you have a passive margin. Along a passive margin, you have no geological activity, so usually you don't have earthquakes or volcanism. So let's compare active and passive continental margins. So the active margins you find on converging plate boundaries, the passive margins on diverging plate boundaries. The active margins, you find a lot of geological activity. You have high earthquake or volcanic activity. And on the passive margins, you have little earthquake or volcanic activities. So active margins you find generally along the Pacific Ocean, and the passive ones in the Atlantic Ocean. So let's look at some of the features of these continental margins. So in this example here, you see a passive continental margins. And we're going to be looking at each of these in more detail. But the continental margin is made up of a continental shelf, a shelf break, continental slope, and continental rise. And after we're done with the continental margin, we're going to be looking at deep ocean floor features. So the continental margins consist of continental shelf, shelf break, continental slope, and continental rise. And in the lower image, you can see the depth profile, and you can see that the continental margin is very shallow. So let's look at the continental shelf. I put a red box around the continental shelf. The continental shelf is the extension of a continent. But because it's a continent, it is underlain by granitic or continental crust. The sediments that pile up on the ocean floor are mostly from erosion from land. It is gently sloping seaward. As an analogy, think about a parking lot by a supermarket. When you push your cart full of groceries back to your car, it is fairly easy because the parking lots generally have a gentle slope downhill. And this is about the slope of the continental margins. The continental margins, or the continental shelf, is important because you're finding a lot of oils and minerals. and the average water depth is about 75 meters or about 250 feet. So continental shelves are shaped by tectonics. So in the previous discussion, we looked at passive and active continental margins, continental shelves. But it can also be shaped by ocean currents. So fast flowing currents, they can carve out sediments. So if you look at these two images side by side at the bottom, on the left side, you see the bottom contours of the continental shelf along the continental United States. Just take a moment to locate Florida. So you can see the light color is the continental shelf and the darker colors are the deeper ocean. And you can see that around Florida, this part of the continental shelf is carved out. It's carved down or scoured down by the Gulf Stream. In the lower right, you can see the Gulf Stream in this dark red color coming out of the Gulf of Mexico and whipping around the coast of Florida and scouring out the continental shelf. And the last component that can shape continental shelves are changes in sea level, low sea level versus high sea level. So during the last ice age, when the water that was evaporating out of the ocean was accumulating in the big ice sheets in the northern and southern hemisphere, sea level was lower. So during the height of the last ice age, you could have walked out to the edge of the continents, to the edge of the continental shelves. Passive margins have generally continental shelves that are wider. So in this image, you can see the continental shelf along the Gulf of Mexico. The black color in the background is the land, and you can see the continental shelf. The brownish color are higher elevation. And what's very typical for the Gulf of Mexico are these pock marks along the continental shelf, and that has to do with the salt tectonics. Active margins, on the other hand, have shelves that are generally narrower. So here you see the narrow continental shelf of the coast of Southern California. In this image, the pinkish tan color is the land, and the turquoise color is the continental shelf. And in this image, you can see how the continental shelf drops off to the deep ocean floor. And you can see these canyons incising the continental shelf. And we're going to be talking about these canyons in a bit. The widest continental shelf we have in the Arctic Ocean. So here we are looking at the Arctic Ocean from a bird's eye view. You can see Greenland in white because it's covered by an ice sheet. Going clockwise next to Greenland, you see the Canadian Arctic, Alaska, crossing the Bering Strait, and looking at the Siberian shelf, you see part of Norway. So the Siberian continental shelf is the widest continental shelf that we have. It's about 800 miles wide, which is about 1,280 kilometers. And the Arctic Ocean is tectonically fairly quiet. Let's look at the continental slope. On the diagram in the lower right, I put the red box around the continental slope to make it easier for you to locate. The continental slope is the transition between continental shelf and the deep ocean floor. The sediments that accumulate on the continental slope are mainly from the continental shelf. It is steeper than the continental shelf. It's about 20 kilometers wide, which is about 12 miles. The depth generally is about 3,700 meters, which is about 12,000 feet. And the bottom of the slope is the true edge of the continent. The shelf break, I have the red arrow pointing to it, is the abrupt transition from continental shelf to the continental slope. The continental shelf has a surprisingly constant depth worldwide. It's about 140 meters deep, which is about 460 feet. And you can also think of the shelf break as the nick point between the continental shelf and the continental slope. So we have a profile of the Florida coast. A cliff more than 1.6 kilometer high, which is about a mile high, marks the edge of the continental shelf west of central Florida. You can see the Florida coast in black. The continental shelf has these brownish colors, and the deep ocean floor is the blue. So the very steep continental slope seen here is unusual. And currents have removed much of the material which would otherwise be found at the base of the slope. So submarine canyons are features found on some of the continental margins. They cut into the continental shelf and slope and often are terminating on the deep sea floor by forming these fan-shaped wedges of sediments. These canyons are usually perpendicular to the coastlines. And here's an example of the Hudson Canyon off the New Jersey coast. So you can see perpendicular to the coastline, you can see the Hudson Canyon indicated in these lighter colors incising the continental shelf. You see another example of the continental shelf in central California. So the brownish and yellowish colors are the continental shelf and the blue colors are the deep ocean. And we can see several of these canyons incising the continental shelf. So nature doesn't like to have these kinks in nature, these abrupt changes in height. And so these submarine canyons are trying to erode the continental shelf down to the same level as the deep ocean. These canyons are scoured out by these turbidity currents. These turbidity currents are a continuous cascade of sediments, and in this example we see the San Lucas submarine canyon off the coast of Baja California in Mexico, which may be eroding a narrow gorge, and about 100,000 cubic meters of sand slip down this canyon every year. So these turbidity currents are fast, dense currents of water that carry sediments offshore. These turbidity currents are scouring out the canyons. And earthquakes along active margins can trigger these turbidity currents. Then the final feature of the continental margin is the continental rise. Again, I put a red box around it so it's easier for you to locate in the image on the lower right. The continental rise forms as sediments accumulate, and often they are seen as an apron of sediments that cover the bottom of the continental slope. The sediment thickness can vary depending how much of the sediment is being carried to that site. The thickest and the widest continental rise is located at the Bay of Bengal, just south of Bangladesh. Here we have major rivers entering the ocean that erode the Himalayas, and the sediments from the erosion of the Himalayas end up in the Bay of Bengal. So you can see the brownish and the lighter blue colors. These are all the sediments that are piling up. Before we conclude this topic, I have 3 quick concept check questions. And again, I give you a little bit of time to find the correct answer. If you answered D, you answered the question correctly. All of the following is true about continental shelves except continental shelves are submerged margins of continents. This statement is true. They gently slope seaward. This statement is true. They are made out of granite. The statement is true because they're made out of continental crust. The statement that is wrong, they are made out of basalt. The continental crust is made out of granite, and the ocean crust is made out of basalt. So here's the next question. If you answered D, granite basalt transitions, you answered the question correctly. This transition from continental crust to oceanic crust is the true division between continents and oceans. And here's the last question. If you answered A, you answered the question correctly. So if you drill into a continental margin and you pull up a sediment core, what you see, the rock that you're bringing up in that core is most likely granite, continental crust, because you're on the continental margin. And this concludes our second topic of this chapter.